Welcome back to the deep dive. So today, we are moving far beyond just renting a server or storing a file. We are stepping right into the intellectual engine room of the cloud. I mean, this is where data stops being a liability and starts becoming, the single most valuable asset you own.
That's absolutely right. Our mission in this deep dive is, well, it's focused entirely on that computational brain of the cloud.
Artificial intelligence, machine learning.
And data analytics, yeah. We're looking at the sources to show you exactly how organizations use these tools to process just petabytes of information and, crucially, either predict the future or, fundamentally understand the past.
It's still wild to me how quickly the perception of AI shifted. For decades, it was those, pure science fiction humanoid robots.
Right.
But the core concept, as the source material makes so clear, is just advanced mathematics. It's pattern recognition, but applied at a scale that was, previously unimaginable. It's not magic, it's just optimized math.
Exactly. And we already learned how to store the data cheaply and securely in the cloud warehouse. Now we learn how to make it useful.
Okay.
So the structure we're analyzing today splits pretty neatly into those two worlds. You've got the prediction engine, that's AI and machine learning, and then the historical truth finder, which is data analytics.
Okay, let's unpack this. We can start with the AI and ML side, because that's often the shiniest part.
For sure.
And the sources give us this fantastic structural analogy for how it's all organized. They describe AWS organizing its AI capabilities into 3 distinct layers, like a cake.
A tiered system, yeah.
Oh.
It's designed to serve every single skill level, from the PhD researcher all the way to, say, a mobile app developer.
So tell us about that foundational layer, the bottom of the cake.
Okay, so the bottom layer is reserved for the true machine learning scientists, the people who need ultimate control. This is the realm of frameworks and infrastructure. If you are a hardcore ML researcher, you need access to raw parallel processing power. That means direct access to specialized hardware, things like P3 instances equipped with massive interconnected GPUs.
Okay, hold on. If I'm not a scientist, what does a P3 instance or massive GPU actually do for a model? Is it just speed?
It's more fundamental than just speed. It's about power. Training a deep learning model involves performing an enormous number of matrix multiplications, all at the same time. GPUs are specifically designed for that kind of parallel work, so this layer gives you raw access to that power, plus the major open source frameworks like TensorFlow or PyTorch. This is where you literally build the computational brain from scratch, customizing every little parameter.
That sounds incredibly specialized. And I mean, time-consuming and really resource-intensive.
It is.
So if I'm a standard application developer, and I need a custom model for a new feature, but I don't want to be an expert in server configuration, why would I ever choose the bottom layer?
That's a great question, and it's exactly why the middle layer exists. If you want to build and train custom models, but you hate all that operational complexity, you move up to Amazon SageMaker.
SageMaker.
Think of SageMaker as the integrated development environment, the IDE, but built specifically for machine learning.
So it manages all the heavy lifting for me.
Precisely. It's a fully managed service that helps you build, train, and deploy your custom models really quickly. It automatically scales the servers when you train the model, shuts them down when you're done, and it handles the deployment endpoints. It streamlines the whole process.
So you can focus on the data and the model.
Exactly. On the model architecture, not the hardware.
Okay, so infrastructure on the bottom, a managed developer environment in the middle, and the top layer, that seems like the immediate payoff.
The top layer is the gold standard for immediate utility. This is AI as a commodity.
That's me.
Right. These are pre-trained AI services accessed via simple APIs, and they're designed for users who don't want to know anything about machine learning. They just want the result. It's plug-and-play intelligence.
Exactly. You just send your data, a picture, a paragraph, an audio file to the service, and the service sends back an intelligent answer. The sources give us some really clear examples of this. We can group them by function: vision, voice, and language.
Let's start with vision then. That's so instantly relatable.
That's Amazon recognition. You send it an image, and it returns object identification. But it's not just, recognizing a face. It can do deep analysis.
Like what?
Like, that's a dog, it's a golden retriever, and it appears happy. Or, this person is wearing a helmet and a safety vest. It gives you real insight without you ever writing a single line of neural network code.
And then we have the voice and language tools, which are they're necessities for handling modern customer interaction.
Oh, absolutely. Look at the audio tools. Amazon Polly handles text-to-speech. You send it plain text, and it speaks it out loud in these highly realistic human-like voices.
And the opposite of that? The opposite is Amazon Transcribe, which is speech to text. You send it audio, say, thousands of hours of recorded customer service calls, and it instantly writes out the text.
Which makes that massive archive suddenly searchable and analyzable.
Instantly. And the power of that engine, Amazon Lex, is what gives us the conversational experiences we expect today, like the intelligence behind those famous conversational assistants.
Right.
Lex is the core technology that drives those powerful, intelligent chatbots. It handles all the natural language understanding and dialogue management.
Okay, but here is where it gets really interesting, though, when we talk about the new frontier, generative AI. The services we just listed, they analyze existing data. Generative AI creates new content. The sources introduced Amazon Bedrock as the key player here.
Yeah, Bedrock is strategically critical. It standardizes access to the next generation of AI models. It's designed as the easiest way to build and scale generative AI applications using APIs without managing the enormous complexity of the models underneath.
And these underlying models are what we call foundation models, right? The massive brains trained on the whole public internet.
Correct. Bedrock allows you to seamlessly interact with these incredibly powerful foundation models. This includes Amazon's own models like Titan, but also powerful third-party models from companies like Anthropic or AI21.
So it simplifies vendor choice.
And infrastructure management, yeah.
So if I were an organization and I wanted to rapidly build a sophisticated customer service bot that could draft polite, context-aware emails or generate unique marketing copy,
right,
I wouldn't need to commit billions to training my own massive model. I would just use Bedrock and plug into the best foundation model for my use case.
That is the strategic insight right there. It turns cutting-edge generative AI development from this huge research project into a much more accessible engineering task. It makes that power instantly available at that top layer.
Okay, so that's the first big world. AI and ML using data to predict the future or generate new content. Now, we shift gears to data analytics, the historical truth finder.
Yeah, analytics is all about making sense of the noise, answering questions about the past. And this is a crucial point. None of the AI models we just discussed can function unless the data underneath is accessible and, more importantly, clean.
So before we even analyze, we must clean. What service handles that vital step?
The sources point to Amazon Glue. Glue is your extract, transform, and load your ETL service. Think of it as the data preparation specialist.
Okay.
Raw data comes in messy, different formats, missing fields, errors. Glue cleans it up, transforms it into a standard format, and then loads it into a destination, like a data warehouse, making it ready for querying. Without Glue, data scientists spend like 80% of their time just cleaning up junk.
Understood. Glue cleans the data. Now let's talk about querying the massive amounts of data we have stored in S3. The sources highlight Amazon Athena, which solved a major historical pain point.
Athena is it's pure architectural magic for S3.
Magic. I like that.
Think back to all those massive log files we're storing. Historically, to query that data, you had to write custom scripts or spend hours moving the data into a dedicated database server first. Athena completely bypasses that.
How does it manage that?
It lets you run standard SQL queries, we call it serverless SQL, directly on the files stored in your S3 buckets.
Without moving the data.
Without moving the data or setting up a server. You just point Athena at the bucket, type, for example, select count from weblogs where country of France, and it gives you the answer instantly. It only charges you based on the amount of data at stand.
So it's perfect for quick ad hoc checks.
Exactly.
But what if the data volume is truly petabyte scale? And I need dedicated, complex reporting that has to run every day across, say, 10 years of history. Athena might get expensive scanning all that data over and over.
And that's the key distinction. For enterprise-grade, dedicated reporting and massive time series analysis, you need a specialized data warehouse. That is Amazon Redshift.
Okay.
Redshift is designed specifically for these complex analytical queries.
So what makes Redshift the heavy hitter here?
Its key feature is that it uses columnar storage, not row-based storage like a traditional database.
Which means?
It means it's insanely fast and highly optimized for analytical jobs, especially when you are aggregating data across massive tables. If your CEO needs a dashboard showing global sales trends over the last 10 years, and it involves joining sales data with inventory and logistics data, Redshift makes that complex multi-year analysis economically viable.
So Athena for the quick serverless lookup on files, Redshift for the dedicated high-performance historical analysis. But what about the data that never stops flowing? The sources mentioned Amazon Kinesis.
Kinesis is the solution for streaming data. This is real-time analysis, and it is a huge competitive differentiator.
A fire hose of information.
That's the perfect term, a true fire hose. Things like a stock market ticker feeding millions of updates per second, logs from millions of IoT devices, or the live gameplay data from millions of video game players all at once.
And the value here is the ability to act on that data instantly, right? Not hours later after some batch process runs.
Exactly. Kinesis ingests that data immediately so you can analyze it as it happens. It allows for instantaneous decisions, like alerting a security team to an intrusion the moment the logs show a suspicious pattern, or calculating a personalized stock price feed in milliseconds.
Okay, so we have the core analytical process mapped out. Data comes in via the stream, which is Kinesis, or it's stored in the warehouse, S3. It's cleaned with Glue. And then we either query it serverlessly with Athena or run deep reports with Redshift.
You've summarized the data movement and analysis perfectly, but raw numbers, even if they are clean and fast, aren't enough for human consumption. We need to visualize that insight.
Which brings us to Amazon QuickSight. What does this tool add to the mix as the final step in the pipeline?
QuickSight is the visualization layer. It connects to all our data sources, Redshift, Athena, even S3, and it converts those complex numbers into interactive dashboards and, well, beautiful graphs.
But it's more than just a graphing tool.
Way more. Here's the crucial insight. It uses machine learning itself.
I remember reading about that. It actively looks for anomalies, right?
Correct. It doesn't just display the data you asked for. It has an ML brain that looks for outliers and patterns you didn't even think to query.
Okay, give me an example.
For instance, QuickSight might flag, based on historical trends, sales are unusually low in the Northeast region today. It provides the automated insight, not just the static data point.
So it elevates the analysis from reporting what happened to telling you why it might have happened or what's weird.
Exactly.
That completes the circle. We can see the entire data pipeline now described in the sources. You ingest the fast-moving data with Kinesis, store it raw in S3, clean, and prepare it with Glue.
Analyze the historical data with Redshift, visualize the results with QuickSight.
And then you loop that knowledge right back into the prediction engine.
That's the full continuous learning loop. You take those analytical insights and feed them into SageMaker to refine a custom model, or maybe use them to ground a foundation model through Bedrock.
I love how seeing these interconnected services demonstrates that the cloud is so much more than just renting capacity. It's a fully integrated nervous system.
It really is.
Okay, let's lock this knowledge in with 3 application scenarios. This is for you, the listener, to synthesize these tools.
All right, bring on the real-world problems.
Scenario 1. Your company is running a massive video game, generating millions of log files per minute showing player activity. You need to identify and flag cheaters instantly, within seconds, not at the end of the day. You also want to transcribe any in-game voice chat from those flagged players for later review. Which 2 core services are you using?
Okay, so ingesting and analyzing millions of records in real time. That's Amazon Kinesis for the streaming data ingestion.
Right.
And once Kinesis captures the voice chat audio, you need to turn that into text for analysis. That's Amazon Transcribe. Synthesis solved. Kinesis feeds transcribe.
Perfect. Scenario 2. You are launching a new mobile shopping app. You need a pre-trained feature that automatically identifies shoes and clothing in user-uploaded photos. Separately, your marketing team needs a one-time SQL query against all the raw photo metadata stored in S3, not in a database, to see how many photos were uploaded from California last month. What 2 services solve these 2 distinct problems?
Okay. Identifying items in a photo without building a network. That means using a top-layer vision API, that's Amazon Recognition, and running a one-time SQL query directly on files in S3 without provisioning servers. That's the classic job for Amazon Athena.
Excellent. Final scenario. You are the lead analyst for a global financial firm. Every day, you have to generate a complex, highly customized report. It tracks every client transaction across 20 countries over the last 5 years. The report is so complex it takes hours to run, requiring massive aggregation and multiple table joins. Where is that core historical data housed and queried?
Right. When you need dedicated petabyte-scale, complex historical analysis and reporting that relies on columnar storage for performance, you absolutely need the heavy hitter. The answer is Amazon Redshift.
Fantastic. We have officially covered the brains of the cloud operation, moving far beyond just renting a server and delving into sophisticated analysis and prediction.
We've really seen the sheer power available to transform raw data into actionable intelligence, whether you're a data scientist building a model from scratch with P3 instances or a marketing manager using a pre-trained API like Poly.
That brings us to the end of the core computational stack. So next time, we wrap up the fundamental concepts with Module 9, focusing on security and compliance.
Oh, that's critical stuff. You can build the fastest, smartest analytical brain in the world, but if it's not secure, it's a liability. We'll be looking at the shield that protects everything we've built today.
And before we go, here's a final provocative thought for you to consider based on the material we've covered. We discuss how generative AI tools accessed via Bedrock use foundation models trained on the vast public internet. Now think about the truly unique proprietary data housed securely in an organization's private Redshift data warehouse. How will those two distinct data worlds, public generalized knowledge and private competitive facts, be securely and strategically blended? And what new form of highly specific proprietary prediction will emerge when you can safely and strategically connect your Redshift data to a billion parameter foundation model? Something to mull over until next time.